Hello friends, this session is going to be a very important and a very useful protocol called as MQTT. This is one of the very important protocols that works in session layer or message layer, we can say. We have seen in detail the IoT stack in my previous session, where you can see that there are 7 layers which we have discussed, and in that we have got a layer which I am highlighting right now with my pointer, which shows you the session and message layer. Here is where my MQTT or COAP is going to work. So this session is entirely about MQTT, where I'm going to tell you what it is. I'm going to also give you a demo as in how do we implement it, how do we use MQTTs as a protocol. I'm going to tell you all those. So just recollect the stack, go back to the video if you really want to have a look at it once again, and then come back here. So MQTT works in layer for messaging, or it works in the layer for sessioning. You can take it either way. MQTT is nothing but MQ telemetry transport. It is also referred as message queuing telemetry transport. Before we go into details of what is MQTT, it is extremely important for us to understand what is telemetry. The dictionary definition says it very apt. It says that telemetry is the process of recording and transmitting the readings of an instrument. It is what IoT is all about. I am going to take a reading of temperature, pressure or humidity through a sensor, and then I am going to record it, transmit it wherever needed, whenever needed. This is all about telemetry. So the definition is very clear. So MQTT is a protocol which is going to help me in this complete process of IoT stack, where I'm going to get the data from the sensors, upload it into the cloud, and then transmit it wherever needed. It is a lightweight protocol. It is also referred as a protocol which is very comfortable for any applications which does not have much of the resources available. So that's the reason we call it a lightweight protocol. It is actually based on a publish subscribe model. It's not client server model, it's a publish subscribe model. The term is to be used is publish subscribe model, so we cannot interchange the term. And who designed it? It's by Andy Stanford Clark for IBM and Alan Nipper. It was in 1999 they designed it, and it was initially proprietary, then they made it free. Now what is it? How does it work? There are many important players in this MQTT protocol, but there is a very important player by name central broker. So who is the central broker? You can see that here there is a central broker who is available here. What is the role of the broker? This broker is used to dispatch messages to the one who needs it. Simple. Now I have got a publisher here. Who is publisher? A node which wants to send the data to the cloud, and from there to the subscriber. It's called a node. So I am sending the data, humidity data, and the data is received by, the message is received by MQTT broker, and I have many subscribers here, out of which one of these subscribers might have subscribed for this data, whereas subscriber 2, you can see that subscriber 2 has not subscribed for it. So whomever has subscribed for this humidity data will get this data. That's all. Now the data which is sent to the MQTT broker will be dispatched to the one who subscribed for it. That's exactly the point. It dispatches the message to the one who subscribed for it. The publisher is the one who sends the message to the broker, and the broker is the one who dispatches the message to the subscriber. The subscriber is the one who takes the data further. That's it. Now what will happen? Will all the messages be received by everyone? For example, I am sending temperature data, humidity data. Will that be received by all the subscribers? No. The subscribers will look into the content, and only if they have subscribed they will be sent with the data. For example, if you have not subscribed for a particular channel, you won't get it in your DTH. So you need to subscribe. So that's the best example that I can give you right here. And there is one more thing that we need to remember here. The messages that are sent along with the topic. Humidity data is a topic. Temperature data is a topic. Whenever this topic, I'm clearing the screen now for our convenience. So let me erase all the data. Now this is a topic. Now this humidity, when I send, the subscribers will see if they have subscribed to this topic. This is a topic. Please remember the term topic. And whenever the subscribers who are seeing this humidity data which they have not subscribed, it won't be shared with them actually. They won't get access to this humidity data. So the broker will take care of this and he is going to send the data only to the one who subscribed for it. Now you can take the TV and radio broadcasting example here, which is very apt. The radio stations broadcast. There are many radio stations available. There are many TV channels available. They keep broadcasting. Whichever subscriber wants, whichever viewer wants that particular channel, they will go into that particular channel and they will watch only that. They are not going to watch other channels. So please understand, whichever subscriber, whichever viewer wants to subscribe to a particular channel, they will choose it and they will watch it. They will not be getting all the channels, whatever they have unsubscribed or non-subscribed also. And here there is a minor change that we need to understand, or minor point that we need to understand. Here I am clearing it again. This is a subscriber. I mean, this is a publisher. This particular node has published some data. Now we call these as subscribers, right? The subscribers can also publish. The subscribers can also publish data which can be taken forward to the broker, and then from them the messages would be read by the appropriate subscribers again. If I am a subscriber, it doesn't mean that I will keep quiet always by receiving data. It can also enable you to send data. It can also enable you to publish data. Now what is publishing? Publishing is posting the data onto the cloud. That's it. Which cloud? We will choose it later. Don't worry about it now. Now what is the topic? Clients does not have any address here. In this schema, the clients does not have any address. So we need to throw the message with the topic. The topic is nothing but humidity data, temperature data, pressure data. On seeing it, the particular subscriber will be enabled to get that message for which he has subscribed, which means the filtering happens appropriately through this topic alone. Based on this topic alone, the filtering happens. You need to understand that point. Now how does it work? I have a client. I have a couple of other clients also available here. This client is publishing data through the broker. The broker sends the data to the subscriber. That's it. Now this guy is a client, this guy is also a client, this guy is also a client. One of them has become subscriber, one of them has become publisher. That's it. Please understand. Now what is MQTT client? It collects information from the sensor. Point number 1. It then connects to the broker. Point number 2. And then a topic shall be used to publish this message to make sure that other clients get the data. Then an MQTT client can also be a subscriber, in addition to publisher, it can also be a subscriber. It doesn't mean that they can always subscribe or they can always publish. They can be both. Now what is a broker? The broker is a mediator. That's it. Here is where the entire protocol works. So let's make it simple again. There is a client who has got some sensor data. He is going to post it to the broker with the topic. The broker will send that to the appropriate subscribers, and that's it. This is what MQTT is all about. Now there is a quality of service content also connected to this total MQTT picture. We have 3 levels of quality of service: 0, 1 and 2. 0 is simple, which says that the message will be delivered at most once. This is called best effort delivery. 1, which says that with acknowledgement, a retransmit will happen if there is no acknowledgement, which means at least once delivery. Third one, exactly once. That's all. Not more than once I will send you. Now we have tried demonstrating this through our very simple previous exercise that we have carried out. I have interfaced my MQ05 sensor or MQ02, both are almost the same, with my NODEMCU, and then I used ADAFRUIT cloud with MQTT to demonstrate the MQTT publishing process. The code is very simple, the process very simple. I am going to now show you the picture where we can clearly visualize the demo of the entire process. I have demonstrated it, followed by the code walkthrough. I have also explained this code very clearly in my video demo. So if you have any queries, you can ping me through the chat option that we always reply. Now let's go to the video demo where you will clearly understand the entire process along with the code. The MQTT publishing process is what is explained here. Stay tuned. I'm going to talk about the complete process in which MQTT publish is going to work. So how do I demonstrate is very simple. I have got MQ05 gas sensor, which we all know. I have already connected it and I have shown you demo with MQ05. So the MQ05 has been connected to my NodeMCU. You can see both here. So the MQ05 to NodeMCU connection is all explained in my previous videos. If you have any queries there, you can probably look into it to get a clear understanding. It has got 4 pins, out of which 3 pins are used here. I am going to use the analog pin, and the analog pin will help me in collecting the data, which means the gas data from the existing environment into my NodeMCU. And I am going to use cloud, which is nothing but ADAFRUIT cloud, with which I am going to prove you the concept of, or help you in understanding the concept of MQTT publish. So what do you mean by MQTT publish? It is all about uploading the data onto the cloud. This is a client. The client is going to get some data, which is a sensory data. It is going to publish the data onto the cloud. That's it, is what is going to happen. And you can see the demo, which will help you in understanding how exactly it works. And I have already explained you the complete story about MQTT. The code walkthrough is also to be done right now, which will make your understanding clear and concise. Now see that I have used the same Arduino interface, so the IDE is all the same. Now the first line is all about ESP8266 Wi-Fi.h. What is it meant for? It is meant for my Wi-Fi module, which is embedded as part of my NodeMCU. You can see that here the NodeMCU has got ESP8266 Wi-Fi module. So it's straight, there is no rocket science here. And then ADAFRUIT is the cloud that I am going to use, so I need to include ADAFRUIT MQTT client.h. And to which pin of my NodeMCU I am going to connect my gas sensor. I am going to connect it to A0, so I can show that here very clearly. The pin is A0, and I think you can see it now pretty clearly. The A0 is the pin that I have connected, so I need to mention that clearly out in the code. So the hash define gas A0 is done, and then I have a Wi-Fi connection which is given through my hotspot, and the Wi-Fi username is Sriram, the password is Sayari$1, and I am going to connect my data. I am going to upload my data to the cloud. The cloud name is iofruit.adafruit.com, and that's the website you need to log in really. And the port 1883, that's a commonly used port here. And username, what is this username? This username is the one that we are going to use to log in into io.adafruit.com, and Sriram KV is the name of the username. I mean, that's the username that we need to use to log in, and there is no password that we need to use here in the code. Instead, you will have to generate AIO key. What is AIO key? ADAFRUIT IO key. That's all. That's a very unique key. You need to generate it, and that key has to be used here. I have already explained you the procedure as in how to generate this key, and I can show you that once again also in my interface here quickly, so that you can understand how exactly it works. You can see that here view AIO key is an option available in ADAFRUIT login. So you can see that your ADAFRUIT active key, your AIO key is available here, and regenerate AIO key will help me in generating one other key. So it's very simple process, no difficulty here. You can see the AIO key from here, and it is unique for every user. So that's the one that we have used here in the code. Now the next step, I am creating an instance of my Wi-Fi client ESP, and this is how I am going to use ADAFRUIT client, MQTT client. MQTT client, in the bracket you can see that ampersand ESP, which means this instance is passed. This particular instance is passed. What is the server name is io.adafruit.com, that is clearly passed. What is port 1883, that is passed. Username and key, that is available here, and that is passed. Now what do? You have established, you have tried to give all the parameters that are required towards logging in into io.adafruit.com, and that's done. Now what are you going to do? You are going to now publish your feed, which is nothing but your gas data which you are going to take. So how are you going to feed it? ADAFRUIT underscore Mqtt underscore publish feed. You can see that ADAFRUIT underscore Mqtt underscore publish. What are the arguments that you need to pass? Ampersand Mqtt, username we already know. I have created the feeds gas underscore data. This is the name of the feed which will start collecting the gas data. It is a very simple understanding stuff which you can probably develop when you look into the code for the second time. And now setup. What is setup? I normally used to set up the baud rate in all my codes, so that's what has happened here. The baud rate is set up and then followed by there is a delay. These are all printf statements. There is nothing. It is just to tell you that I am connecting properly to the ADAFRUIT cloud. Now I am now going to connect to the Wi-Fi, and you can see that here Wi-Fi.begin with Wi-Fi and password. If it is done properly, if it is connected properly, that's all fine. If it is not connected, I need to look into that also. Now I am just printing Wi-Fi connected, IP address, etc., etc. Now let us go to the next level where you can see that MQTT part really comes here. So what do you mean by MQTT? I already told you that we have seen enough about the introductory stuff. Now I am going to read the data which is after the connection, which is after establishing the connection. Analog read is the simple stuff that we are using, and once it is read, I am going to feed the data. So if feed.publish data is available, I am going to say it as success, else I am going to call it as a failure. And this is a very simple stuff where I am just printing the data back onto the screen. That's it. So I am collecting the data here. This is analog read. I am printing the data here, and this is all just to get a message saying that it is successful or it is failure. Now what is the thing that you need to understand? You need to understand what is this particular point, what is this ADAFRUIT underscore MQTT underscore publish. This is called publishing. Subscribing is one part, publishing is one part. I have now shown you how to publish through the gas data whatever you have got, and this has helped you in understanding it. Now we will see how exactly it works as a real-time demo. Now I have uploaded, I have compiled it. I am just uploading the code into my NODEMCU so that we can see the live demo. This has been already connected to my Wi-Fi through the code, I mean my hotspot through the code. Now you will have to wait for a few seconds to really see if the compilation process is all done right. And one thing that I would like to stress upon here, even after coding so many times, I forget to select the port. So you need to see that if the COM port is ticked properly here, you need to see this COM port is ticked properly here. If not, it won't work, you will get a bug. So make sure that you look into it carefully, otherwise it could be a bug. So now the burning process is on, so you can see that it's all happening and the uploading is happening right now. This is a regular process, there is no difficulty here, it's very simple. Only thing that I want you guys to do is to practice this once. How did I just write the code? The code is very simple. I just established the connection, I just fed the data, it is called publishing. I am now printing the data. So you can also see the data in the serial monitor, which I am highlighting here. You can see that here in the serial monitor, and you can also get the instance, get the copy of the data in the cloud. It is now 100% done. So what I am going to do is, I am going to just check in the serial monitor if data is going to come. So the gas data is arriving and it is success. I am going to blow air now. You can see that there is a minor variation in the so the data is going in. That's the point that you need to understand. And how do we see this in the cloud, sir? Very simple. I'm going to go to the feed, and in the feed you can see that there is a gas data, and in this you can see that the data is coming 713, 718. The data is continuously coming, and this is called ADAFRUIT Publishing, Mqtt Publishing exercise. In the next exercise, I'll show you how exactly to subscribe. Thank you very much. I'll get back to you with more contents shortly. This entire exercise is done in order to just get you accustomed to the process. I hope we made sense, and I'm going to get back to you with the complete method to subscribe to the feed that is already available. So MQTT is discussed today. We will come back with MQTT subscription process tomorrow. Until then, it's bye from me. Thank you very much for following my channel. I'll get back to you with more updates shortly. Thank you.